Thanks, Suju ma'am, Ravindra sir, Prashant sir, Ashish sir. Okay, so let's get started. In our previous session, we have covered on the seventh module, the primary portion. So we are going to see one of the challenges that happens when two miners try to parallelly. Thank you so much, ma'am. Parallelly, try win the contest, right? We have seen how they win. Now we'll just revise a little of that and then move on to this challenge that is there in this. And coming to the eighth model that we plan to cover today, because towards the end of the seventh module, Professor Pandurangan sir's, the portion of that particular lecture completes. So eighth module is taken by Satya Peri sir, which is more on the consensus protocol, right? So we will be covering consensus in our next session, right? So I'm just going to start my screen share. Great. Okay. Amazing. So let me see if my screen is visible to everyone. Got it. So in this seventh module, we were looking at a few challenges that are there when which is related to the threshold. So we have also revised in our previous session also the contents of the block, the contents of the header, right? So before we move forward, like let me go ahead and also set context for people who have recently joined. Right, so people, if at all you have recently joined, let's say in the past month or past week, do not worry. Right now, we are doing this hackathon where we revise the actual lecture covered by our primary faculty here, Professor Pandurangan sir. Right. So now we are in the seventh module. We have just finishing the seventh module, and if at all you plan on starting, you start from the beginning itself. So let me point you out how to go about it. So if you see, this is how your teachable will be, right? And in this particular module, we are currently in module 7. But I'd request you to start from the beginning if you're recently joined, right? Do not worry how the hackathon flow is. Right now we are in the 7th module. You need not have to catch up, and it is even difficult for trying to fully catch up at once, right? So one thing that you can do is start from the beginning and also parallelly attend hackathon, or start from the beginning and watch the corresponding recording of the hackathon. You don't have to join the current one, right? If at all you are, let's say you are in third module or second module and you have any query, because the hackathon or the revision is going to be of the same lecture. So pretty much if you can go through that, you are good. If let's say you have any query, let's say in module 3, you can bring that query to your module 7 or current hackathon session also, right? I hope this is clear. You need not have to worry on catching up on the hackathon where we are, right? That is how it goes. So now let's begin. So if that is clear for the people who have recently joined, you can type directly to me, see in the chat box, right? So people who are already, going in the flow, and it's all normal for you. Okay, so we've seen what are the contents of the block. In that, we have seen what is block header. In that block header, we have seen what is Merkle root, what is the difficulty in our previous session. Before that, we have seen what is nonce, right? And we have seen each of these things in our previous sessions, right? Now, we also tried to understand how a common consensus or a common agreement is there among all the nodes, that who wins or who creates a block, right? So that is where we have tried understanding more about mining process and nonce, where each of the attempt is recorded by a miner, and when that nonce or the attempt number, whatever he is doing in a sequence or a random way, is going to concatenate it with the transactions that he is uploading on the block, and he's going to hash it, right? So let me go ahead and show that. So this is what we have discussed previously. People who have recently joined, do not worry. We covered this in a clear way in our previous sessions also, right? So nonce is the number only that can be used only once, right? And this acts like a counter for the person who is mining, right? When that is concatenated with the transactions that the block has and all of the hash, if it is being hashed, and that being less than a threshold, if this condition is met, that person becomes a winner. So he's eligible to construct the block, to receive the block rewards. This is what we have previously understood, and how difficult the generation of nonce is also we have understood, because the probability of generating a nonce is very very small. So a person has to do a lot of hashing to actually find the nonce to fit the condition, this, right? Hash of the transactions along with the nonce less than threshold, right? So now we're not going into the depth of the probability of it and all. So we have discussed what is nonce, then we have understood what is threshold, right? So the threshold is the value that gets updated every 2016 blocks, right? So every 2016 blocks, it takes the average of the previous blocks, 2000 blocks generated, and then sees that tweaks the threshold in a way that creation of each block, irrespective of the performance of their system or the node's device, be it a super performing system or a regular system, it should take 10 minutes amount of time, right? So this has been system generated in the initial phase, like it could be 2 to the power of 224, meaning that if somebody hashes all of the transaction, he has that number along with the nonce, the hash of the whole of that particular value should be less than this particular number, which is 2 to the power of 224, which is a very huge number, crores of crores, right? So very big number. And the probability of someone who's trying to generate a nonce and be less than or within this threshold is 1 by 2 power 32. 2 power 32 is 410 crores, right? So 1 by 410 crores is like almost zero only, right? So very tough that a person generates it. So, and that is the difficulty involved in mining. And that is the reason this 2 power 32 is called the unit of difficulty, right? So many times what happens is a person, the hashing happens quickly, right? Some computers hash, in terms like thousands and lakhs at once. So this still happens, but a person has to hash 2 power 32 times also, and there's a possibility that he'll not be able to make the hash less than threshold. Like he'll not be able to find a nonce that will make his hash less than threshold, and he will start again, right? So then that if he's doing it twice, thrice, he's taking, that is the amount of difficulty it is that he is putting in, right? So that is the amount of work that he's putting in. So we have understood the unit of difficulty in our previous session, right? So this is all covered. And then we also understood that because sometimes what happens is if the threshold becomes higher, the difficulty will reduce, or when the threshold is less, right? So the lesser the probability, already it is a less probability. If you make it even say the chances of you winning is out of 100, you will be in the 25 people. If you are in the 25 people, you win. That is a different probability. If you should be in the first 1 to 5, that is even complex, right? So the difficulty increases. So that is the reason we have seen that this threshold gets updated. It keeps on updating for every 2016 blocks, right? So this is what we have previously discussed. The time it takes for creation of a block with all the computation, verification, validation, and adding that block to the previous blockchain, it all takes 10 minutes, right? So this is some given value that we have. So now how do we set a threshold value so that more or less this amount of time that is being consumed for creation of a block is always roughly 10 minutes. Why it might change, right? Some people, if they have a supercomputer, might be able to generate the block in 5 minutes only, right? And we do not want that, right? So we do not want a few miners to use high computational power and have lesser work, or generate a block less than 10 minutes. So that is the reason, because with time the computation power increases, and people will be able to generate blocks in lesser time than 10 minutes. The threshold keeps on updating, right? So that is how it gets oscillating between. And we have also seen in our previous session from the beginning of time how the difficulty has increased, right? So we've all seen that. I'm also going to show that once. So for everyone to have a common blockchain, so this will extend to our today's session. For everyone to have a common blockchain, every 10 minutes a new block gets added. And if you remember, in our previous sessions we have seen that if a block gets added, it takes roughly 1 hour to have 6 confirmations. Because if you remember, we said 1 hour. Why it takes 1 hour? Because each, if you need 6 blocks above it, the height of the block should be 6 blocks above it, meaning each block taking 10 minutes, it takes 1 hour. So now you can relate like 6 confirmations, meaning creation of 6 blocks, meaning 6 into 10 minutes. There it will take 1 hour for anyone to have a confirmed block uploaded. It's not likely that one person uploads the block, 99% the block is going to be confirmed, but there is a slight chance that that block also might get rejected for 2 reasons. If there is some manipulation done in any of the transaction, the block will get rejected. This happens many times. But what happens is, if there is one person who has won, and there's immediately within a few seconds only, let's say within 10 seconds, there's another person who has won. In that case, only one person is going to be the actual winner. So that is what we will check today, right? So in these 2 cases, the blocks can get rejected, right? So now we also understood hash rate is the number of hash operations a computer or a node can do in 1 second, right? So as time progresses, technology improves, hardware improves, the hash rates come down. And if the hash rate is, hash rate reduces, like the more hashing can be done, right? So now the hashing rate increases with technology. To adjust that, the threshold is adjusted in a way that every block that gets created should take 10 minutes amount of time. So now this is what we have understood. The work that system wants a miner to do is 10 minutes always, right? Give or take. Now, which means the work that will be done is the time in seconds, 60 minutes into 10, so 60 seconds into 10 minutes, 600 seconds into his own hash rate. So that is the work will be done by each miner. Now we have seen in our previous session that how do we calculate a new threshold based upon the previous threshold, right? I'm not going into the derivation part of it. So this is a simple one. So we have seen that the new threshold is equal to the current threshold into the average time taken for generation of those blocks by 600, right? So the average time taken, whatever is taken for 2016 blocks, divided by 10 minutes. So we want it to be in 10 minutes by 600. If you divide it, if you multiply it with the current time, you will get the new time, right? So every time is a new threshold. So we divide it, we multiply it with the current threshold, we get the new threshold. We'll see an example here. Now, what we have done here is, what is the average time taken? So what is the average time taken is the average time taken to generate 2016 blocks. So normally the average time taken to generate the 2016 blocks is always taken. Normally, if you see here on the right side, for example, there are 2016 blocks, addition of all the times from beginning till 2016 divided by 2016, you'll get the average time. So that is how you're going to get the average time. And this is also system calculated. Yeah, Prashant, go ahead. Is this related to the current module or is it anything previous?
Hi, Sachi.
Yeah, please go ahead.
This is related to this current module, but what I'm trying to understand is that are we trying to talk about the mining capability of a miner? That's what we are trying to
correct
talk about.
Yeah, I'll help you understand that. Anything else that you want to ask? Like, what is the question here?
Yeah, that is my question.
Okay, so now the mining capability of every node or every miner will be different, right? So because if you see, for example, if my system has more computational power or if it has more advanced, then its hash rate will be higher, meaning it will be able to create more hash or create generate more operations of hashing, right? So now
depends on the
computational power
capability of the GPU, right?
GPU or the whole setup that they have, that is what it takes. Now if you look at this, what is going to happen, because every person has a different hash rate or a computational power or GPU, what is happening, we want the system, the blockchain, when the genesis, the starting of this blockchain happened, there were a few parameters set default, right? There is a set threshold or difficulty that was given as a system parameter, and that is set in a way that every block it should take 10 minutes for generation, right? Just because my system has,
that's assuming, right?
That's not assuming. It's a given. It's given that.
It's a given.
Yeah. So if because you've recently joined, I really appreciate you coming up with the question. In our previous sessions, what we have done is we have seen that this is a system parameter. Every block on the blockchain, a new block gets added every 10 minutes. Even today.
Okay.
For example, after 10 minutes from now, there will be a new block that gets added. So it's it's minimum that much amount of time that takes. And after every 10 minutes, a new block, when it gets added, it takes another 1 hour to become permanent. Not all, it doesn't mean that if you have a block that got uploaded or connected onto the blockchain, there are chances that it might get rejected because, for example, I have uploaded a block or onto the system, I've pushed the block onto the system. Maybe there was some error I made, or there was a transaction where I tried doing some manipulation. And when other people, because it's a peer-to-peer, right? When the other people see that there is the hashing is not accurate and there is some error that is coming in, they reject, they do not confirm your block. And if you require 6 confirmations, meaning you require 6 more blocks to get added, then only your block is going to be 99% confirmed, right? So this
let me stop you here.
Yeah, please go ahead.
Yeah. When I'm trying to add a block, the others have to confirm the block, right? Not by adding blocks, 6 more blocks.
Yeah, so now confirmation happens in this way. So whenever the other miners or other nodes are uploading their block, they will have the hash of the previous block. When they validate that it is the confirmations can happen by a new node or even from all of the nodes, right? So it roughly takes 12 seconds to reach 85% of the nodes, right? So that the new block got added, and anybody can confirm, right? Because, for example, when a person uploads a block, all of the details are there in the header. Like, let's say there is nonce, which means the attempt at which his hash was less than threshold. So what they will see, the current threshold is set amount, and they will do the hash of it and check, okay, his nonce was successfully getting submitted in the equation. the hash of the whole of the transactions in the block with his nonce or his attempt number is less than threshold. For that reason, he's the winner. So I am confirming this. So whenever a new block gets added, it only gets added when he confirms the previous block. So when you have 6 blocks, it means that everybody had to confirm the previous blocks, right? So that is how this happens. Maybe I'll explain this better.
Yeah.
Confirmation.
Yes, thanks for the answering my question, and I think I'm taking so much time. Maybe
no worries. I think I understood. Here your doubt comes because in general scenario, we think that confirmation is like, okay, this is correct. But whenever a new block gets added, that is also a confirmation of the previous block, right? So when 6 blocks get added, meaning that your block was confirmed only for that case, the block got extended, which means it is a confirmation, right? So if somebody was like, I don't want to, I see there is a problem in this particular block, they'll not add their block, like the blockchain will not continue. So if new blocks are getting added, those many number of confirmations are there. So I'll show it onto the real-time system. It will become clearer for you.
Yes, Shashi, thank you.
Yeah, thanks for the questions. I really appreciate it. You're also starting from the module 1. You have already started.
Yes, just barely gone through.
Yeah, so you go parallelly through there also, and when you start coming near this block, everything becomes more and more clear. But I see that be easily able to go through. It should not be a problem. Yeah, thank you so much.
If
anything, you can always reach out.
Sure, thank you.
Yeah, thank you, Prashant. Yes, Ravindra sir. So Ravindra sir asks, 6 will be the consecutive and new block adding has to be right only when previous part is used. Yeah, Ravindra sir, if your question is whenever a new block gets added, a new consecutive block gets added, which means that the previous block is getting confirmed. If that is what you are saying, I think you're right. So when you have 6 new blocks, or you will have more blocks, right? So for example, you can have 10 blocks ahead of your block, which means you had 10 confirmations, right? So for example, from now there were 100 blocks before, right? Today, if let's just say it is 100 and 200th block, if the 100th block was there have been 100 confirmations for that block. Only after 6 confirmations, we can consider it is permanent. If it is 100 confirmations or n number of confirmations, it is definitely permanent. If it is more than 6 or equal to 6, it is confirmed, right? Yeah, so that is what we'll see. So we'll see in what case it does not get confirmed, right? So we'll also see that now. Thank you, Ravindra sir. At least it should be 6 to be sure that this is a confirmed block. You're right, sir. Yeah, correct. So now we have, that is clear that here we are in a way talking about the computation of the capability of the miner, not exactly. We are also talking about how do we have a fair way that even a person who has higher computation ability, mining ability, and a person with lesser mining ability do enough amount of work that on an average it takes 10 minutes to create a new block. Okay, it's amazing. So now we have understood in a previous session that whenever there is a new threshold, whenever after 2016 blocks, this is also a system parameter. Like after every 2016 block, the difficulty gets assessed again, the threshold gets adjusted. So the new threshold formula after every 2016 blocks is current threshold into average time by 600, right? So we have understood this. Now we'll just see one example that professor takes in the session, right? So let me once show this link shared by professor, which is btc.com stats/difficulty. I'm also sharing this on chat. Now you see when it was roughly like say 2010, 12, 14, the difficulty has, after a point of time when there are more and more nodes, after every 2016 blocks, the difficulty kept increasing, right? So that is what is being shared here. And now you can see that in this, there is a list of what has been always the average time that it took for creation of 2016 blocks and what was the threshold at that moment, right? So it is all recorded. In our previous session, we have seen an example of this, these two rows. Okay, I'm able to select. Now we have taken these two rows where 6,768,000 plus 2016 becomes 6,02,784. Now this set of 2016 blocks between, we have seen that the average time was for this new 2016 10 minutes 46 seconds, meaning we wanted it to be 10 minutes. It is a little higher, and if you tweak it now, make the threshold in a way that it takes lesser time, right? So now how will it take lesser time? You have to decrease the difficulty. When the difficulty is decreased, the time also will decrease. So the threshold has to be increased. That is how you will have to tweak it. Now here, if you see this one column called bits, this is where the threshold is stored, and this is stored in hexadecimal exponential format, right? So I'll also explain that with Professor Pandurangan's example, right? So if it is clear that in this link, all the difficulties and thresholds have been saved, and how the average time keeps on getting updated after every 2016 blocks. If you're clear till now, which is what our previous session was, if you're clear till now, type C in the chat box. Thank you, Sujam. Thank you, Ravindra sir. Okay, so now we'll move on to today's agenda, which is trying to see if the equation is proper. Thank you, Prashant. If the equation is proper, right? So now what we're going to do is, in our case, we are going to copy this threshold, which is this, okay? So now what I'm going to do is, I'm going to use hexadecimal to decimal converter. Professor does it manually on the screen. For our ease, I'm just going to do hexadecimal to decimal, okay? So I'm just going to use this tool. What I'm doing here is, now this particular threshold, in this 0x means it is hexadecimal, right? So it's a notation only. So 0x is not part of our equation, like not part of our threshold. It says that this is in hexadecimal format, and 17 is the exponent of 2 power 256, so 256, right, in hexadecimal. So we'll also come there. So this 6 characters that we have are the actual hexadecimal number, which we need to convert into decimal, right? So now I'm going to enter the hexadecimal number. When I convert it, it becomes 13,47,295. Now before that there is 17, which means because the threshold is a higher number, it's a very big number, you'll not be able to put it in this small number. So what it is, the format is called the exponent mantissa format, where the 17 is the exponent, right? So in hexadecimal, it is the exponent, which will be multiplied with the binary number that you have here, right? So this is what Professor does here. Now, if you see this equation, the same 171480df, this is the old threshold, and we saw that it took 10 minutes 46 seconds, which means 646 seconds. Now, if you slightly increase the threshold, now it will become easier for a person to get the nonce, right? So for that reason, we are going to adjust the threshold in that way. So now how do we convert? Now we also know that the next threshold in the next value is this, right? So this will be on the equation in that particular database, right? So now what we are doing is, we have got this number 1480df is 1347295. So now this has been done manually. For the people who have recently joined, what sir has done is, now 1480df, to convert it into base of 16, you do it in this format. Let's say 0, 1, 2, 3, 4, 5. Now 1 into 16 power 5 plus 4 into 16 power 4, 8 into 16 power 3, and you go till f means 15. So you write all of that and do a summation of all that and you get it, right? And this 17 number is the exponent number, right? So now 17 also 1 into 16 power 1 plus 7, which becomes 23, converted here into as the exponent form. The actual the 1480 df, is exponent 2 power 17 in hexa, which is 256 power. So 256 power 17 in hexa is 256 power 20 in decimal. You multiply that with the number. So this is the whole threshold, right? So this is what we have seen till yesterday. Now what we are going to do is, the new t equation is the old t into the average time taken by 600. So if we just, because we have now new t and old t and the average time, if we bring the new t, the old t here, which becomes new t by old t, if both of this are equal, right? This division and this division, if they are equal, which means the new threshold value, this equation is proper, right? So now what they have done here is, the new threshold value is let's say 13, the old threshold value was 1347295 into 256 power 20. The new threshold value is 1450193 into 256 power 20. So that gets cancelled out. So this is what is remaining, right? So if you are just wondering what happened to the 256 power 20, that got cancelled out, and this is what is there. And if you try doing the division of the same, you'll get both places 1.076, meaning that this is the equation. This is how a new threshold value gets calculated every time, right? Sometimes it gets reduced, sometimes it gets increased, right? So let's go ahead and verify here. And the new threshold is 171624. The division of the new threshold by old threshold, or the average time, old average time, the average time by 600 is always going to be same, right? So you can do it with all the two sets of 256 2016 blocks average. You will get the same result, right? So this is what we have understood. Now if we just closely look, if this is clear, this calculation verifies that the new threshold is old threshold into 646 by, or the average time by 600. So if you're clear, if you understood this, type U in the chat box. Yeah, so people who have recently joined, do not worry. This is all covered in a step-by-step manner in our previous sessions. So once you go there, it will become easier, right? Thank you, Prashant. Thank you, Ravindra sir. Thank you, Sujapa. Great. Now, the equation is also there. And coming to Prashant sir, your question, in our previous sessions, we have also seen something called the Bitcoin Explorer, where I'll just clarify on the confirmations portion, right? So now the blockchain.com, we go to Explorer. This also is shared in our previous sessions. So you can, you don't worry, you don't have to worry about the links and everything. So now we are going to check one block, which is the 5 lakh block. This we have done previously. So I'm going there already. Now you can see that there are 3 blockchains with our result. Now block 5 lakh. So we are going to open block 5 lakh. Now, if you see after 5 lakh block, there are like roughly 2 lakh over new blocks that got created, right? So we'll understand what is confirmations that are happening here, right? Okay, now there are a lot of values included here. A few of the important ones are explained in our previous sessions, like starting from what is the input and output, all of these, right? So do not worry, don't get overwhelmed here. We are going to just see a few things, right? So now you can see that this block has 2,700 transactions within that block, okay? And now we also see that the nonce value, if you remember, the hash along with the whole of the hash of whole of the transactions along with nonce should be less than the threshold, right? So the hash is also given here, right? So the hash, the nonce is also given here, which helps anyone to verify or confirm this particular block. We have understood what is the Merkle root, the difficulty, right? So if you remember, the difficulty also is here now. Now, if you see height, now what is height? Height means if, for example, there is starting block 0 and there are 2 more blocks, the height of the third block is 3. So at what position a block is, that is the height, right? So now, if you see depth, meaning after your block, how many new blocks have been created, right? So now after 5 lakh block, there are 2,79,998 blocks that got created. 10 minutes each block, roughly 10 minutes each block. So those many blocks got created. So when this block was created, the time will also be mentioned somewhere here. Okay. Okay, I think it should be here. So this was mined on December 19, 2017. So in the past 5-6 years, 2,79,000 new blocks got added. Now, if you see, the depth and the confirmations are same, meaning there are 2,79,000 blocks that got added, which is same as the number of confirmations. So whenever a new block got added, that many times this block got confirmed that, okay, yeah, this is a valid transaction. The miner found the nonce and all the transactions in this particular block are valid and genuine ones. So this is what this whole statement says. Now you can see that here distance or time means like this was created 5 years before, 5 years, 2 months before. Now this is what this whole of this is explaining, right? So now before going to all of these things, I just want you to understand the confirmations is whenever a new block gets added, it gets confirmed. I hope this is clear for you both, Prashant sir and Ravinder sir. Right? Confirmations should be clear. Great.
Yes, Sachi. I think I'm getting somewhere. No need for Sar and all. Prashant, it's okay.
Okay. Thanks. Thanks, Prashant. Yeah, so it comes out of like a default thing. So thanks for that.
Yeah, I understand.
Yeah, now let's see. And now we have validated the equation is also correct and the threshold gets updated. Now, in a very rare case, right? So regular cases, whenever there is a new block that gets created, it gets rejected before 6 confirmations, only because whenever somebody is trying to confirm, sees that the transactions hash is not proper, or there is some manipulation done there, or there is some transaction input, something is incorrect there, right? So the hash along with the nonce maybe is less than threshold, is not, the equation is not true, right? So for that reason, it does not get confirmed. That is easy, right? Because it has some fault in it, it got rejected, did not get confirmed. But there is another rare case where it does not get confirmed, where within seconds of one miner creating a block, there is a new miner who also creates another block. This is a rare case because first, creation of the block is only rare, right? And second, because it takes roughly 10 minutes on an average for a person to create a block, it is very rare that he creates very close to the previous block that is created, right? In some cases where there's a supercomputer, it took 5 minutes also. Now 5 minutes, before 5 minutes only, this block, the new block, the news of that the new block got created is already circulated within 12 seconds to 85% of the nodes. A new block came onto the for verification pool, right? It is up for verification. So it's very rare that within seconds, some miner also becomes a winner, right? But let's say what happens in that rare case also, we're going to see, right? So is the rare case clear now? Like what happens? What is the rare case? The rare case is what happens? There is a parallel winner. right? If that rare case is clear, type C in the chat box.
Sachi, in this case, are the transactions same in both?
No, it will be different, right? So because there will be like huge number of transactions in every pool, yeah, they'll be different. They'll be different. Great. So now, if the thank you so much, ma'am, for the question. If the problem challenge is clear, the case is clear of a parallel winner, type C in the chat box. Now we'll see what is going to happen. Yeah, thank you, Ravindra. Now let's just say there are 100, like there are 99 blocks that are already confirmed on the blockchain. And then there is one person X, let's say going by professor's example, one person in Singapore confirms, and there's another person, let's say A, who confirms another block roughly around the same time. Now, what happens is both of them say the previous block's hash, they'll put the previous block's hash connecting that block to the new, right? Now, because it takes some time for, circulation of this block, it continues, like both of them think that, okay, I'm the winner, and they still wait for it getting confirmed. There are very rare chances that it will not get confirmed. First thing, he's happy that he won, right? His block got validated and everything, he won, but the reward is not yet given to that person. Both of them say, okay, then they are waiting. Now what happens is, because this person ignores A and this person ignores X, right? So you just can go ahead, connect your block to 99, what was the previous block, right? And next what happens is, there's the same person or some other person after 10 minutes, say, creates another block. Say there is X1 and there is A1, right? Two more blocks got created. Now this person sees this A as a new block. Let's say even in this example, we are thinking that the same block, the same person uploads another block. He got X and he got X1, and the other A person, he got A1. Now what is happening is, he is still going to ignore what is this X1 happening. He is going to continue with this flow, and this guy is also going to continue with this flow. Now there's another person who comes, A2, and he sees A1 as a valid block, right? Now what happens is, because he connected to this block, one block becomes longer than the other block. There's always case like both blockchain before confirmation will not have the same length. One will always be longer. So whichever is longer, that is confirmed, and the other chain, which is not yet confirmed, whichever is shorter, that both of those transactions will get rejected. Though this X person and X1 person they won, the chances, because the longer, there was another chain that got created, A2, because some people will get this as confirmation and some people will get X as confirmation, right? The more number of confirmations happening. And because there are more confirmations starting onto this A block person, and because this became a larger block, now these two blocks get rejected, and the reward also they'll not get. The reward is taken by A and the A1, right? Longer means more transactions or more connects, right? So for example, there are 199th block, 100 when both of them added, 100 on X, 100 on this chain, and there is 101, and let's say there is another transaction here, which makes this the longer chain, and that is the reason this both two, because it has to be same for everyone on the blockchain. We cannot have multiple blockchain versions for everyone. Now, because it has to be same for everyone, they reject this particular two blocks that got created, and those two people have to come back again onto the upload them back again after A2, right? So that is a very rare case. But what happens is, when two people actually win together, roughly around the same time, then more confirmations, the person who has more confirmations or becomes the longer chain wins. The other person, after some time, the block gets rejected, right? So he'll not get the block reward. And then he has to upload it once again, right? So whenever he gets confirmation, after like say 6 blocks from there, he'll get his block reward. Right. So this is the rare case that happens when we have 2 parallel winners. Only thing that we have to remember is the person who gets more confirmations becomes the actual winner. Right. So let's say the new confirmations become the judge of who becomes the winner. And that is how this goes. Right. So if this is clear, type C in the chat box. Yeah, so if there's any other question also, you can go ahead and ask. We're going to keep our session short. This is going to be the conclusion. We'll be concluding our session with this particular understanding of this case and take questions. Yeah. So is it clear that when 2 people win parallelly, the blocks that has more confirmations or becomes the longer chain wins, that person wins, and the other person's blocks get rejected and they have to upload them again and connect them back again. So if this is clear, type C in the chat box. Yes, Prashant, you had any question?
Yeah, this is like an amateur question.
No, please, there's no amateur question. There could be amateur answers. Please go ahead.
Why do we have so many coins? And I mean, not only Bitcoins, there are so many coins, right? The proof of concept for existence of all the coins is somewhat different from the concept that Bitcoin uses.
True.
Right? Why are there so many coins? Can you please?
Yeah. So even this particular question we have not discussed anywhere in all of the models. Maybe briefly somewhere. But each of the coin, like right now, we are currently discussing only blockchain, right? So whenever
blockchain in the sense Bitcoin
is Bitcoin, we are only discussing Bitcoin. So now any person, any new altcoin, the other coins apart from the blockchain are the altcoins. Whenever it's a new coin that gets created, it has its own some uniqueness, right? So they bring in, like when you see the Bitcoin blockchain network, it is more of a cryptocurrency only. Like it's more about the transactional or financial transactions. That is what is happening. But now if you look at Ethereum, now what happens is Ethereum as a blockchain is more usable when you want to automate things, right? So when you want to create applications over that. So it has most of the systems same as the Bitcoin blockchain network, but a few enhancements where you can see that it has made basically either it has used a different script or language within its own system for having a better verification system, maybe having a faster verification, or maybe giving an option to build some application over the network. So whenever and we know today that there are n number of coins are coming, but there are some primary coins or primary networks that are always preferred, right? So some people directly create coins as an investment opportunity without some things. Like there is one coin which is, okay, so you can go ahead and show you. I think it is the coin. Yeah. So anyone here knows the coin which is always equal to the dollar value? Okay. Thank you. Give me a second. Ether. ETHER. Okay, I think it is Tether. Let me just give you an example.
Yeah.
Yeah. Yeah, so let me go ahead and share my screen again. So now there's like a new coin here, which is Tether, right? So now if you see this coin, what it did is like every other coin has its different application. Now this coin is always equal to 1 USD value, right? Now if you see today, if it is always equal to 1 USD. Now what application this has is when you are trying to do financial transactions in Bitcoin. Now Bitcoin conversion, dollars, it's always a challenge, right? So people can send tethers, which is nothing but like a dollars. Like for example, if I send 2 tethers, which is $2, which becomes a little easier. You can later convert it or get it into your wallet, get it into cash. You upload dollars, convert it into Tether dollars. It's like just exchange, right? So now many every coin has its own application that they come up with, and all of this is defined. Like if you go ahead and enter that particular coin, it says how and what differentiation that they prove. Like some are just like fancy coins, like if you've seen the Doge coin or some, which are trend coins, which just for some trend, some fancy thing they have made. So there are different applications, but some serious applications, if somebody has to build, then they'll try to either do it on Ethereum or like the other primary things, right? So there are sand coins and other coins which are used for virtual in the crypto real estate or the NFTs and all. So you don't have to actually worry about all of this, right? So why there are more, because everybody has some unique problem that they want to solve with that particular coin.
Yeah, understood. And thanks for the answer.
Thank you so much. Thank you. When Ravindra sir says when blocks are rejected, they will have to start once again, as I suppose. Yes, sir. For uploading later also, they have to work. I think I would want to get back on this. Would they have to work again to find the nonce? I think I also not thought it through in that manner. I understood my assessment from Professor Pandurangan's sessions was that they can directly upload because it already found a nonce which will be less than threshold. The nonce is not gone yet, right? So I don't think they will have to restart because they have found the nonce which will be when hashed along with the transactions, which will be less than threshold. Yeah, that is what my conclusion would be, but I would want to come back in our next session. Yes, thank you so much for the question. Thank you, Suju ma'am. Yeah, thanks, Prashant, for the question, because we are not actually discussing other coins previously. Most of our discussion is always on the Bitcoin system. When we go towards the Solidity block, Solidity modules, then we'll discuss more about Ethereum. Right? So most of it was on this, but your question always adds value.
Great. Yes, thank you, Sachin.
Thank you. So this brings us to the conclusion of the whole 7th module also. Now we are going to, in our next session, which will be on Tuesday, we'll see the consensus portion, which was taken by Satya Peri sir, right? So we planned on covering consensus today itself, but because there was some change, that a few things that happened from module 7 to module 8, we're going to start freshly in our next session. Great. Thanks for all the questions. If there's anything, you can always reach out. If you're starting from the people who have recently joined, if you're starting from the beginning, bring your questions to our next session also. That is completely fine. Right? So we'll have doubt clearance happening there. Okay. Even our other members who have answers to your questions can also add in. Great. Thank you so much, everyone. See you in the next session.
Just Sachi, one thing. like I think so far about 3 in MCQs as part of the lab, there
Okay.
have been certain problems like relative time log time and so on, like a presentation in groups.
Okay.
Now we are actually studying through this, of course, recorded one.
Yes.
Course of the Professor Panditang. Now, how are we to do that? Of course, we are doing ourselves, but it has to be answered and sent to you, isn't it?
Yeah, it has to be. So
what are you supposed to do? Yeah,
I think you can directly send that over email to Pixeltests, madam. So wherever you find.
Now the thing is, like it is we should make it like a presentation, as a PowerPoint presentation, and also talking, both the video of our audio presentation also, as well as a PowerPoint presentation. Yeah, how are we to do, or just answer alone, or write up?
Yeah, so the presentation should be enough. You are in the module. Which module, ma'am? This question came in.
No, there are 3 places I have seen. One is on hashing, the use case of a hash. Then second was a verification algorithm.
Understood.
Then I think module 6, there is relative log time.
Understood.
Yeah, there's 3.
I suggest
part of the.
I suggest you present that maybe in a Zoom recording or something. You present that and share it. Becomes easy because presentation, we want definitely the presentation, but when you explain it, we know that it's also understood. So yeah, so I think that's the way.
Sort of a video, is it okay? Or a video?
Yeah, so maybe how you can do it, if at all you have Zoom, you can as a single person record that and send that recording.
Okay.
Share screen, your video is on, and you record that and share it to us. Should be good. Or you can use other applications for recording your.
Yeah, some other applications.
Great.
Okay.
Thank you so much, ma'am. Yeah, this also clarifies for others also, people who are doing in module 6, 7, the hashing and the other modules. If you're doing the lab portion of it and you come across towards the end a few sessions where there was a group activity where a presentation was to be made and presented, you can do that and send it to j@pixeltest.com. So I've shared that on the chat. Thank you so much for the question, ma'am. Yeah, so Prashant sir, thank you. Yeah, it's always a revision for everyone. Great. So see you in the next session where we'll talk more about the consensus. Thanks, everyone. Many thanks. Thank you so much.